Alright, so residuals. Basically, all that means is the difference between what our predicted value is and what the actual value is. So on our line here, this would be the predicted value at 20. Here's what the actual measured value was. So this difference here is a residual. Now I had to zoom in because this was a very good fit, so the residuals were very small. Alright, if the residuals are larger, that means there's a weaker correlation. Alright, so let's look at what our predicted height for 20 months is. All it means is we just plug 20 into our prediction equation here, our regression equation. So we do that, and that gives us 76.61. Now, what was it actually on our table? On our, what am I doing here? My bad. So at 20 months, we had 78.1. So here is the actual, because this is what was actually recorded as the average heights, 78.1. Here's our predicted, because we used our equation to get it. So you can predict or use your prediction equation or use the regression equation for data inside your range, even not just like the 36 months we did earlier. So the residual, since this is above the line, it's positive, and it's always the measured or the actual minus the predicted. So if we did actual minus predicted, that would give us a 78.1 minus 77.614, and that's going to give us a 0.486, positive residual 0.486. That's our residual value. A few quick things to talk about residuals. We're not going to be harping on these a lot, but a residual plot is if I took all these distances and plotted them above or below this line. Basically, it'd be like taking this line and laying it flat and then marking how big these distances are. So for the first few, this is below but barely. This is right on, it looks like. This one's a little bit above. This one's slightly below, maybe a little below. Slightly above, a little below. And basically, we can look at a residual plot, and this is the take-home idea. One, what a residual is, and two, if there's a random pattern to our residuals, then the linear model is a good fit. Okay, there should be kind of some above, some below, and a residual plot should kind of look like this. If there's a non-random pattern to our residual plot, which is just the plotting of the distances above and below the line, that's bad, so that linear is not a good fit. That's the basic idea there. Alright, so this is all you have to do. Now, I said only pick 8 species, so you can pick any 8 data points. Alright, the idea is many kids will pick different sets of input values, and we'll probably get very similar regression equations if this is a good linear data. So pick 8 species, or more if you want, and then go to Excel, make the regression line, answer these questions, and we'll see you next class.